I'm Anil Kumar, and in this set of videos, we are going to understand behavior of the function near the asymptotes. In this example, we'll consider vertical asymptotes and infinite limits. Question is, check the discontinuity and state the equation of any vertical asymptote for the function f of x equals to x squared divided by x squared minus 9. Conduct a limit test to determine the behavior of the curve on either side of the asymptote. So we are given the function f of x equals to x squared divided by x squared minus 9. So let us write this function in factored form. So we could write this as x squared divided by x squared minus 9 could be written as x plus 3 times x minus 3. Now we want to find equation of any vertical asymptote. Now vertical asymptote is possible when the denominator is 0. That is to say, when x plus 3 times x minus 3 equals to 0. That implies that at x equals to plus 3 or minus 3, we'll get vertical asymptote. So that is the first part, right? So those are the 2 points where we do have a vertical asymptote. So what we can do here is kind of sketch the vertical asymptotes. Right? So let's say that is the coordinate plane, and let's say one asymptote is at x equals to minus 3. I'm not using any scale, but generalize. We'll just assume this is at x equals to plus 3 and minus 3. Okay. So the point here is x equals to minus 3, and here it is plus 3, that is the x-axis, and that is f of x. These lines show us the vertical asymptotes at plus minus 3. Okay. Now second part of the equation is conduct a limit test to determine the behavior of the curve on either side of the asymptote. It really means that what is the limit of the function f of x as x approaches the asymptote from left side and from right side. That means when you approach minus 3 from left side, that is from negative side. That is, if you are approaching from this side, then we do have a vertical asymptote, but the function approaches either positive infinity or negative infinity. You need to figure that out, right? So this is what we need to test, correct? The function given to us is, we could write this as limit of the function when x approaches minus 3 from negative side. That means the function is here x squared divided by x plus 3 times x minus 3. Now what happens when you take a point which is very close to 3, but it is kind of on the left side? That means you have x value which is, let us say, minus 3.1, right? So think like minus 3.1. That means you are on the left side, right? Now, if I substitute minus 3.1 here, we'll have positive in the numerator, correct? So that will give me positive. If I write minus 3.1 here, this will become negative, correct? And this will be also negative, correct? So when we have positive and two negatives, we expect a positive answer. Do you see that? So the limit will be positive infinity, positive infinity. Do you understand? So you can substitute and find the answer. So that is to say that the function will approach positive infinity. When you are approaching from the left side of minus 3, you get an idea, right? Similarly, find the limit of this function, f of x, when x approaches minus 3, but from the right side. That is to say, if you are approaching from, let us say, the right side means kind of here. So that means think about a value which is minus 2.9. So that is a point which is on the right side. So at this point, what is going to be the value? You can also substitute x as minus 2.9 and check for the sign, right? Whether the sign is positive or negative. This is what we're trying to say, right? So basically, you're trying to find limit of this particular function as x approaches minus 3 from positive side. X square over x minus 3 times, you may write plus here and minus here. Okay. Clearly, numerator is always positive, but if my value is less than minus 3, it's on the left side of, the right side of minus 3, in that case, we know the numerator is always positive here, but the denominators, this value, is going to be positive. However, that value is going to be negative, right? So what we observe here is that when we are approaching minus 3 from the right side, in that case, we will get a negative value, right? Positive divided by positive times negative will give us negative value. So the limit actually approaches negative infinity. That is to say that the graph of the function will go in this direction, correct? So that is a way to find limit of the function close to the vertical asymptote. We could also adopt a table of values and find the limit using table of values. We'll do it for point 3. So let us now find limit of this function as x approaches 3 from left side. That means 3 minus 1, right? And also let's find limit of the function f of x as x approaches 3 from the right side. That means from the right side, correct? We could find making a table of values. For example, let's make a table here with test points close to 3. So we are trying to look at the value 3, and on both the sides of 3 we can take some test points. So on the right side the value could be, let's say, 3.1. On the left side it could be 2.9. So if I substitute 2.9 in my function, then we find that the function f of x approaches 2.9 in this function here. Square will always be positive. This factor will be positive. However, this factor will be negative. And therefore, we approach negative infinity. So when you approach from the left side, the function approaches negative infinity, correct? Now if I substitute 3.1 in the function, then we have positive, positive, and positive. So f of x approaches positive infinity. So it'd be like this. So that is the behavior of the graph of the function as it approaches vertical asymptotes, right? I hope that is absolutely clear. And we could write this as written here, right? And these are two different ways of finding it. In a way, we are testing points very close to the vertical asymptote and checking whether the function's value is infinitely large, positive or negative, and that gives us the idea how the graph of the function is going to approach. I hope that helps. Thank you and all the best.